Hi. Over the years tutoring Python, I found that one topic that a lot of people had difficulty with was object-oriented programming. For that reason, I'm making a bunch of videos on the common mistakes or misconceptions or sticking points that I see with object-oriented programming in Python. I understand if you're coming in for my OpenGL content, this might be at a slightly different level. This is for absolute beginners, but my philosophy is to kind of maximize my coverage and help as many people as possible. So with that out of the way, let's look at object-oriented programming. It all starts with classes, and a class is like a template describing all of the data and functions, all the data and behavior that we want our things to have. So as an example, let's make a class to represent a bone, like a bone in the human body or something. So that's the name of the class, and we'll think of the class as like a template of sorts. We will have some data, and that is the label of the bone, the name of what the bone is, as well as a connection. Now let me just put this through here. So the type of data for the label will be a string, and the type of data for connection, well, that will be a reference to another bone. Okay, so that's our data section. And then for our behavior, or we'll call them methods. Now there's nothing mystical about methods. Basically, a function inside a class is called a method. Okay, so what we're going to do is we're going to have a printinfo method, a getConnection method, and we'll call it a setConnection method. It's very common in Python, very common in object-oriented programming, doesn't matter which language, to have this get and set method for a variable. Okay, so there we have it. That's our basic class. Now remember, a class is just a description of how something will be made. On the other hand, if we go and we make, if I can spell, an ankle and a shin bone or something, and I don't know, like a foot bone, who cares? I mean, it is important, but I don't know anything about anatomy. Then these things are instances of the class. Okay, so again, the class is the description of the data and the methods that something will have, like an object will have, and these solid examples, when they're created, are instances of the class. We can think of this as just a collection of data and methods. Okay, so let's jump in and code this up. Okay, so we're in our environment. Personally, I use Visual Studio Code for all my development. Idle, I'm sorry, just doesn't make the cut. So I'm going to make a class called Bone. By default, well, it's common to start classes with capital letters. Doesn't have to be, but that's the convention. Now, see that we have tabbed over by one spot. So anything that we define here will be belonging to the class. We'll write an initializer, that's 2 underscores, and we'll take in some data. So this code will be run every time a new bone is created. So for instance, now we're back by 1, we're not tabbed in, so we're not inside the class. We'll create a bone, and we'll pass in a label for it, ankle. Okay. So see that label starts here with an underscore. The reason for that is that Python does not have private variables. So it's common when we want to indicate that a variable should be private to the class, it's common to start it with an underscore. Now, what we'll do is we'll define a getter for that label. Okay, fair enough. Now, let's just investigate. What is ankle actually? Let's print it out. This might seem a little intimidating. We've printed this out here. We have this main bone object. Now have a look at this. It's a bone object. Yep. We've called this bone thing, which creates a bone object. We stored it in ankle. Okay. That's in the main code. Yeah, because we're just running it in the script. We're not running it inside something else. Yep, good. And it's at this 0x. Now 0x means a hexadecimal address. Often in computers, addresses are stored in hexadecimal because it's more compact. In hexadecimal, two hexadecimal numbers make a byte. So we have 1 byte, 2, 3, 4, 5, 6, 7, 8. 8 bytes or 64 bits, which makes sense. We have a 64-bit operating system, so we're storing our memory addresses in 64 bits. So this is the place in program space, virtual memory, where the bone object has been created. In other words, when we call bone, we get a pointer or a reference to that bone which was created. Okay. So then the next thing is, what is the deal with this self? What is even the deal? Well, have a look at this. Let's go print ankle get label. By the way, I said don't be scared of this hexadecimal stuff, because if I print this out right now, so you have bound method bone get label of main bone object. So see this? This is, again, it's printing out a memory address, because we're not printing the result of the function, we're just printing the function. We need to call the function. Okay. There we go. Oh, well, what do you mean? Oh yeah, underscore. Important. Okay, then we're printing out ankle. Great. Now have a look at this. So I've tabbed this over so it's not inside the class. Okay, and what I'll do is I'll print get label. Oh no, not bone. On the ankle. And this does exactly the same thing. So this is coming into why we have self. See, if we didn't have self here, this function would have no idea which object it should print the label for. It would not really even know what label means. It would be like, hey, that's undefined, with good reason. So that's why we need self here, because really when we define a method inside a class, that method is not stored in the class. It gets pulled out, defined. This happens under the hood. We don't see this happen. It gets pulled out and defined separately. And then when we get an object and we call the method on it, so we have this dot access the method inside the object and call it, what it really does is it takes this pointer and throws it in as the first argument. Okay, so I'll say that again. We need self because really this method gets thrown outside of the class, and Python takes the thing with the dot, the pointer, throws it in as the first argument. So really it's doing this under the hood. Okay, so hopefully that helps. Now, just for fun, I'm going to complete this class as we defined it and show a bit more. Okay, so we'll make a connection and we'll define setters and getters for the connection. Okay, good. That's looking good. So now I'm going to make a function. Actually, let me just give some more examples. Okay, so we'll have a shin. The foot bone, very technical there. Okay, and then we'll set up these connections. So we'll say that's shin. Okay, so we'll go down the body. So the shin is connected to the ankle. And the ankle is connected to the foot. Okay, good. So again, like I was saying, Python's convention is it takes this set connection, throws it outside of the function, throws it outside of the class. And what it does when we call shin get connection is it takes shin, removes it, throws it in as the first argument in front of ankle. So then shin is the first argument, ankle is the second argument. This is the way it works with class methods. And then when we call this one, ankle is the first argument, foot is the second argument. So ankle's connection gets set to foot. Okay, now I'm going to make another function. Go print info. And this works on a bone. What we're going to do is, first of all, we're going to print the label of the bone. And then we're going to check, is the bone connected to something? So we'll say, okay, if bone get connection is not none. Okay, because by default, when we create a bone, its connection variable is none. That means it's not connected. So what we can do is we can go, okay, print bone get connection. So that returns the bone object that this bone object is connected to. And then on that, we can call get label. Okay, so let's test this. Let's go shin is the top of the hierarchy there. So we'll go print info on shin. Yeah, we have shin. Shin has a connection. So then we print ankle. How do we do this to get all of the connections? Well, I mean, we could just keep repeating, but here's another trick. So bone get connection returns the bone object which is connected to this object. Oh, whoops, I made a blunder. We should be calling this function. Now the reason that worked before is this is the address in memory where the object is. It's the object basically, the function object. The function object is defined, it's a function. We want to know what it actually returns. Okay, so let's go print info and we'll pass in the connection to the bone. Okay, oh no, it's recursion. Okay, so here's how it works. First time we call this with shin. Is shin connected to something? Yes, it is. So print info on ankle. Okay, we go to ankle. Print ankle's label. Good. Is ankle connected to something? Yes, it is. Okay, so print info on foot. We go in, print foot's label. Is foot connected to something? No, it's not. Okay, so it exits there. So let's run this. Oh, what's going on here? Oh, right. Too many prints. This is already printing stuff. We don't need to print it again. There we go. All right. Anyway, so just to recap, today we looked at creating a basic class with an initializer and getters and setters, and we discussed why self has to be here for class methods. Because Python's convention is to take the first thing and throw it in as the first argument. It's automatic, it's done under the hood, but it is definitely confusing. Then we looked at a slightly more fleshed out, example of printing out recursively and checking things. Anyway, I hope you enjoyed this session, and I am going to be making a few more of these on some common kind of sticking points that I see when people start learning Python for the first time. Hope you have fun, and I'll see you again soon. Bye.